Morning folks, it's the 8th of April, let's go! So, starting with Foundation Plus, first question is a truncation. Now truncation you very rarely see, but all it means is to cut the number at that point. So we don't round up, we don't round down, we just write what we've got at that stage. 2 decimal places, make the cut between the 8 and the 6, so it's 5.38. If it said round to 2 decimal places, you'd go up to 5.39. Truncate does not mean that. Next question is a standard find the equation of a line. So the gradient, you just want a change in y over change in x. Again, remember you are counting coordinates, not squares. So we're not doing 4 over 4 here. This is 8 because it's the difference between 16 and 8. And this is the distance between 6 and 2, so that's 4. So 8 divided by 4 gives 2. And you've also can clearly see on the graph the intercept is 4. So we can go straight into y equals mx plus c. Y is 2x plus 4. You could have also done that in a longer way using any of the points on the line, but you should get to the same answer. Next one is about the angle sum of a polygon, and there are 3 rules that you should go into the exam knowing, which are these. That an interior plus an exterior is 180, that an exterior sum is 360, and an interior sum is sides minus 2 times 180. There are 10 sides on a decagon, so 10 take 2 is 8, times 180 gives 1440. If you want to work out the size of a 1 interior angle, you can then divide that by 10, which is what we did here. Or you could do it a different way. Another way of doing it that I quite like is to find the exterior angle and then take it away from 180. So using rules 1 and 2. So the exterior angle is 360 divided by 10 is 36, and the interior is 180, take away that is 144. Same answer either way though. Lastly, we have a reverse percentages question. It says normal prices are reduced by 15%. That means we now have 85% left, and that sale price is 136. If we want to get back to the original price, we should write down 85% is 136, and we can then get to 1% by dividing by 85, and then up to 100% by timesing by 100, or you could divide, I guess, by 17 and times by 20 to get to 5%. Answer will be £160. Another way you can do it is you can think, well, the multiplier for an 15% decrease is 0.85, and if I want to work backwards, I could divide by it. So you could get straight from 136 to 160 by dividing by 0.85. Either way, works out. Cool. Okay. Moving on to higher, it starts off with some indices. Anything to the power of 0 is 1. I did look at that and think, what is 36 degrees? But no, it's 36 to the power 0, it's 1. Power of a half, remember the top number is always your power, the bottom number is always your root, so this is a square root and no power, so it's square root of 49, which is 7. Just assume these questions are non-calculated, by the way. A coin is flipped 3 times, what's the probability of getting 3 tails? So you could do a sort of tree diagram here, where you went like heads, tails, and so on and so on. However, I think the easiest way of thinking about it is just, well, it's tails times tails times tails. That's the only way we can get 3 tails. We're assuming it's a fair coin because the question doesn't say otherwise, although it should really. So it's just a half times a half times a half is 1/8, or 0.125. Okay, we've then got a perimeter question. So this is to do with arc length. And the formula we should know for arc length is that x over 360 times pi d gives you the length of an arc. If it was sector area, it would be x over 360 times pi r squared. It's just like the formulas for circumference and area of a circle, but times by x over 360, where x is the angle of the bit that you've got. So in this case, 30 over 360 times pi times 12 is what we need to do, and that's going to give us 3.14 for this curved bit. But we don't just want the curved bit, we want the entire perimeter, so we've got to add on the 6 that we can see, and the other 6 for the radius. 6 plus 6 plus 3.14 gives you 15.1 centimetres. There we go. Lastly, a little bit of a weird one. So this is frequency polygon. You very rarely see these. Frequency polygons are what you get if you have a histogram, like so, and you draw, it's going to take a little bit of going, isn't it? And you draw basically crosses in the middle of each bar. So you can sort of imagine that the histogram you started with looks something like this. And like but it's not really a histogram because it says frequency rather than frequency density. So all we need to do is just count number of people. How many people were surveyed? Well, there were 5, and then 20, and then 15, and 25, and 1. That's just how high up they are. So add them all up, you get 66 people in total surveyed. Spooky. We then want to get an estimate of a mean. Now we know if we're estimating a mean, we want frequency and midpoint. And we can times them together and do the stuff we normally do. The frequencies we've already calculated. We've got 5, 20, 15, 25, and 1. So I filled those in. And the midpoints are just like, where are these crosses? So we've got 5 at exactly 10. We've got 20 at exactly 30, and so on. And they just go up by 20 each time. So the midpoints are 10, 30, 50, 70, 90. And then we do the same as we normally do with estimating a mean. We multiply to get our fx's. We add all the fx's up. We add all the frequencies up. And then the mean is the total of the fx divided by the total of frequency. 49.1. Cool. Okay, lastly, we've got our higher plus questions. The first question, you want to use something we would call cross-multiplying. So that means that we're going to multiply the 3 by the x minus 1 that's on the bottom of the other fraction. We're going to multiply the 5 minus 2x by the x plus 1 that's on the other fraction. So we'd start off with this line here. That 3 times x minus 1 is 5 minus 2x times x plus 1. And think about them as being, brackets, not just 5 and 2x. From then, it's a quadratic, so you should expand. You should simplify. And what are we trying to do with any quadratic? We are trying to make one side equal to 0. It's like the only thing that quadratics have. So I ended up with 3x minus 3 is 3x minus 2x squared plus 5. I added the 2x squared across. I took away the 3x, which actually leaves me with no x, and then I took away the 5 to get to minus 8. So 2x squared minus 8 is 0. I then divided it by 2, because you can do that with equations, that's fine. And it makes it easier if it's x squared compared to 2x squared. And then we need to factorize that. It's a difference of 2 squares, so it's x plus 2, x minus 2, so the answers are 2 and minus 2. I then went ahead and checked they worked by subbing them back in, and remember this is always something you can do. So I subbed in x is 2 to give me like 3 on the bottom here, 5 minus 4, 2 minus 1, so 3 over 3 is 1 over 1, yep. And 3 over minus 1 is 9 over minus 3. So you can do a check at the end if you're not sure. Next two are two graphs that you need to know the shapes of. Basically, sine and cos, they just go between minus 1 and 1. So it's never going to go higher than 1, it's never going to go lower than minus 1. And I always basically think that something interesting happens every 90 degrees, or something that the examiner needs to look for. So something happens at 90, at 180, at 270, etc. Sine starts at 0, goes up to 1, goes down to 0, goes down to minus 1, goes up to 0. That's what I mean by something interesting. It's just like whether it's going from 0 to 1 to whatever. Whereas cos starts at 1, and then 0, minus 1, 0, 1. If you can remember where they start, it generally becomes quite straightforward to remember the rest of it, because it's just going up and down after that point. Okay, then a little bit of indices again. Minus 3/4, that means we're going to flip the fraction. Because of the minus, we're going to use a power of 3, we're going to use a root of 4. We talked about this loads. So 1 over, because of the minus, and then 4th root, and then 3rd power. So 4th root of 81, now you might not know that, but it is an odd number, so you'd think, okay, the answer to that's got to be odd. It's not going to be 2, and it's not going to be 5, because 5 times 5 is 25, times 500 is getting way too big. But 3 times 3 times 3 times 3 gives me 81, so that's sorted. 1 over 3 cubed is 1 over 27, job done. And then this one, you can do this in the same way. You can think about doing a 4th root of 16 8 to the x to the 8, and then cube it. However, I found it easier to think about the 16 and the x to the 8 separately. Because if you do a power to a power, you can just multiply them together. So x 8 to the 3/4, I could just find 3/4 of 8, and that would give me just x to the 6. Whereas for the number, I needed to think, well, what's the 4th root of 16? That's 2. Cube it, that's 8. So it's 8x to the 6. And then, proof of congruency. So, proof of congruency is basically prove these triangles are the same. And there are 4 acronyms that you're meant to be saying, basically. You're meant to say one of these 4. A stands for angles, S stands for side. So it's either because the angle, the angle are the same, side, angle, side, etc., etc., etc. And then you just basically have to look at what information you're given. It says ABC is isosceles, where AC equals BC. So I wrote that down. I wrote down AC is Y and BC is Y. Put that on my diagram. D and E such that CE is CD. So I said CE was X and CD was X as well. And you've basically got enough information at that point to do your congruency. CE and CD are both X. CB and CA are both Y, because that's what the question told us. See, I've written down in brackets like how I got this information. And then ACD is BCE, because that's clearly the same angle. That's just like this angle here. So if we were to think about the two triangles that we've got, here's ADC, because it talks about ACD and BCE. We've got a triangle with an angle of theta, a length of x and a length of y, and we're comparing it to a different triangle, which is BCE, which has an angle of theta and a length of x and a side of y. In other words, side, angle, side. They're the same because of that. Great. Cheers. Hope that helped, folks. You've got 3 days left, I think. Nice one. See ya.